Today we are going to answer the Jurassic-sized question, can we ever bring dinosaurs back to life using DNA material? We are headed out to a very remote Cretaceous dig site in the Hell Creek Formation, where we're going to be looking for bone samples from a number of different species, including Triceratops, Pachycephalosaurus, Ankylosaurus, Dakota Raptor, Edmontosaurus, and my personal favorite, Tyrannosaurus Rex. Then take these samples to Colossal Biosciences to determine whether or not we can extract any genetic information. Thanks to Colossal for sponsoring this video, and make sure to follow their channels so you don't miss another breakthrough. Oh my gosh, I literally just hit record on the camera.
Did you really?
I literally did. That's Rex tooth, isn't it?
A tip, yeah.
Holy cow.
So he was crunching down on something. This is a shed tooth, and this is a snap off. So he bit down on something so hard that he snapped his solid bone tooth off. That big round of bone, that's a lot of force to break that.
That is a shard from a Tyrannosaurus Rex's tooth. We have been digging for all of 5 minutes.
Great way to start the day.
All right, so Danny, you had something just pop out of the ground. What is that?
So this is a hadrosaur jaw that I just found in here. See, it's pretty beat up. There's a crack in it. So I'm gonna put a little bit of glue in this crack.
Okay.
Just to keep it together.
When you say jaw, what do you mean? Because this looks pretty small. It's a piece of a jaw, right?
Yep, this is the fragment of a jaw. And you can see their teeth would be growing right up in these grooves here.
Oh, wow. And when you're saying hadrosaur, we mean this could be Edmontosaurus,
Yep.
is one of the possible specimens, which is one on our list that we wanted to check off. So just like that, just in a matter of minutes digging here in the channel, and we have definitive bone. And what's interesting about a jaw is I'd imagine there's a lot of blood flow that happens in the jaw, specifically where teeth would be. So this is without question a specimen we want to hold on to, and a piece of this will then be able to take to the Colossal lab. Dude,
Sweet.
Good find. This guy's a bone hound. Looking at this wide open expanse of Hell Creek Formation, you're probably thinking to yourselves, well, what did this look like during the time of the dinosaurs? This was actually a lowland, swampy forest area. Probably would have looked quite a bit like Florida, sort of the northern parts of Florida, with all sorts of big trees, swampy environments, rivers, crocodiles, turtles, all sorts of bizarre reptiles and amphibians, and they were all, of course, living amongst the giant dinosaurs that we consider icons. Triceratops, Tyrannosaurus Rex, duck-billed dinosaurs, even the armor-plated Ankylosaur. Now, what's cool about this site here, what we call the Hell Creek Channel, is that every species in the Hell Creek Formation is represented in this hillside. You name it, if it's in Hell Creek, it has been found here. And we are finding little bits and pieces of each and every one of those specimens in this hillside. Pretty crazy to think at one point this was a swamp, and now it's a complete wasteland. Oh, you dropped it.
There it is.
Ah! Dude, Luke, what is this? What are we looking at?
This is a foot digit to probably a Theslosaur or a Pachycephalosaur.
Dude, another species that we wanted to check off the list. So Pachycephalosaur, for those that don't know, is the dinosaur with the big bony dome on its head. This is something that we can potentially then look at to see if there's any DNA evidence in a bone like this.
There's marrow inside of there. It's all encased, like it hasn't been split open, so all the natural edges of the fossil are there, so everything inside has been protected.
You guys are unbelievable. We're always hoping to find little layers that are either clamshell or clamshell and sand. Like, oh, there you go. There's a perfect example. See that?
Wow, yeah.
That's clamshell, which shows us that this channel was at one point a river, 66 to 70 million years ago. And you have to think, when you look up here on this hillside, that is all the sediment, millions and millions of years layered down to this exact spot where we are finding a section that has Cretaceous treasure in it, including Tyrannosaurus Rex itself. To be digging in the gravesite of a Tyrannosaurus Rex is a feeling that you really can't explain. It's just an aura that is all around us when we're digging. So hopefully something crazy comes out of the ground today. Okay, we turn off the camera, we turn the camera back on. Something else exciting just happened. The Cretaceous Kid, what do you got, Luke?
So there's a little premax tooth.
Dude, is that nano?
Probably nano, yeah, or a large dromaeosaur.
Is a little crack in it, so I'm gonna get some glue on it. I don't like to even glue them before I get them out, because most of the time they're solid enough. You can get them out and it'll save you a lot of time cleaning. But because this one is a little bit cracked like that, I am going to put just a little bit of Starbond on there, just to hold it together while we get the rest of it dug out.
Okay. raptor tooth. Let's go. We're rolling. What did you find?
Oh man, I just found, if it's all there, it'll be the best T-Rex tooth I found this year and one of the best T-Rex teeth I've ever found.
This could be a huge T-Rex tooth.
Oh my
yeah!
Jeez. That is actually insane. Oh man, that's a nice tooth. It is like perfect.
That is like the holy grail right there. Can you put your finger next to it just so that we can see the length?
That's probably a 4-inch tooth, but perfect. To find one in that condition, that size, is so rare.
Yeah, I'm so excited right now. I mean, this is what we live for out here in the Hell Creek Formation, is that moment. And you know, we can dig down deeper and you don't know what you're gonna find. It's why no matter where you're digging, you always just have to be paying attention, because even at this layer, a tooth like that is capable of presenting itself. The serrations are gorgeous.
Oh, they're pristine. So I've got it glued, I've got it kind of perimetered and pedestaled, and it should be pretty easy to break it loose.
Okay, let's see what happens.
I'm a little bit nervous with a tooth this size because it's just a lot more complicated than a smaller tooth, but I'm gonna just kind of wiggle my knife under it and just kind of very controlled and gentle.
Oh my gosh.
And that's the tooth.
Oh my god.
Wow. Can I hold it? That's like my newborn baby, so don't drop it.
That is unbelievable. So with a tooth like this, we'll break off some of the sand on the back, but it will require the prep lab to get this thing looking pristine. That will be one of the next steps. So at this point, we have samples from multiple different specimens in the Cretaceous period, and I say it's a great time to head back to the prep lab and start getting our fossils ready for transport to Dallas. Okay, so this is the process for cleaning fossils. We're using air, a little bit of baking soda, time, and precision. Here we are in the prep lab with our dinosaur specimens prepared. Now, Luke and Danny do a phenomenal job in the field of being able to identify on the spot, but Clayton, we are bringing you in as the expert eye to help us identify which pieces, parts do we have. Let's start with identifying the bones and see if we have captured at least 5 different specimens.
So it looks like this is for sure a Tyrannosaurus Rex.
There you go. Now, how do we know that that is T-Rex?
So, oh, here's another one.
That's T-Rex
and
too.
this is even better example, because you see the porous holes in that.
Yes.
The big honeycomb bone marrow. There's only one dinosaur in the Hell Creek Formation that has bone marrow that big, and it's T-Rex.
Confirmed Tyrannosaurus Rex. That's important. And if there's going to be any genetic material, I would think maybe inside the bone marrow.
It would make more
Could be a
sense.
spot.
Yeah.
Okay, what are we looking at with this bone here? It's obscure looking, and Luke and Danny, we're guessing it's some sort of a hadrosaur.
Yeah, for sure.
Okay.
I can tell these little ridges are where the tooth sockets, where the teeth would go.
Okay.
And there's really only one dinosaur that they're this narrow on, but yet this big, and that's a hadrosaur.
How about this?
That's Triceratops, real almost 100% sure. There's only one dinosaur that has that kind of texturing on the skull. And
Okay.
a lot of the skull is really textured like that. Probably had keratin sheath over some of it.
I'm going to save these little ones for last because I'm pretty sure those are exciting. But what about this?
That is from an old site I had years ago in my Chunkosaur pile. I found it this morning.
Yeah.
And it's a piece of an ankylosaur scute. So this is a club-tailed dinosaur.
Okay.
It's just a random fragment. It's rare to find ankylosaur stuff, so that piece there is pretty cool because they're insanely hard to find.
Yeah. All right. This is also one that you took out of the Chunkosaur pile, which we know we found maybe some evidence of the species. But what are we looking at here?
I think that's just a section, is a small piece of a Ornithian, so probably, I'm almost sure by this texture right here that it's probably a Thesalosaur or possibly Pachycephalosaur.
Okay.
We definitely get both, and the vertebrae are very hard to tell apart. But I think we could safely say this could be Pachycephalosaur.
Okay, so a dome-headed dinosaur of some sort. So again, one of the targets that we had on the list. And finally, and not least, is a form of raptor.
So raptors are theropods, and all these fragments of bone right in here are all from theropods. We get a lot of theropods on our channel. And this is the end of a metatarsal. Possibly, there's 3 species this could possibly be from. Oviraptor, Nanotyrannus, or possibly Struthiomimus, known from the Hell Creek. And they're 3 big theropod dinosaurs, are bigger than your typical raptor foot. This, I'm almost sure, though, I'd be fairly confident saying that's a dromaeosaur.
Okay, which is a type of raptor.
Absolutely.
Yeah,
Yep.
with a hooked claw and everything like that.
Yeah,
so
the killing claw.
That we will definitely consider this without question our raptor piece, even though something like a Struthiomimus would really classify as a dinosaur that falls into that class.
Yep.
All right, well then what that ultimately shows us is that we have got samples from all of the targets that we hope to find in the Hell Creek Formation.
Awesome.
Which we're pretty excited about. Now, whether or not we're able to find any DNA in these bones is yet to be determined. So now I've got to head to the lab in Dallas, Texas to team up with my good friend, Dr. Beth Shapiro, and find out just how they grind down bones and ultimately extract that DNA information.
Welcome to our new headquarters.
This is pretty awesome. I'm ready. I brought you some cool stuff today. Brought this back from Jordan, Montana. Now, we know that one of the biggest questions Colossal always gets is, will you guys be able to de-extinct dinosaurs?
So you brought me an embryo.
We brought you something better than embryos. We brought samples of dinosaur bones. So we've got Ankylosaurus, we've got a raptor species, we've got Triceratops, we have got Tyrannosaurus rex, which we're extremely excited about, a hadrosaur, also known as a duck-billed dinosaur, likely Edmontosaurus, and last but not least, the dome-head Pachycephalosaurus. Will we be able to grind these down and extract DNA information from these bones?
No.
Let me ask you that again, because I think that you just said no. You're telling me we are not going to be able to extract DNA information from these dinosaur bones.
Unfortunately, no. Now, don't get me
My
wrong.
life is in shambles.
This is often the reaction that I get to this.
Yeah.
And I mean, I would love it if we could find a dinosaur bone somewhere that still retained genetic information. But unfortunately, they are all too old.
Okay.
Everything we know about how long DNA survives and the geological history of life on this planet tell us that we are not going to be able to get DNA information from dinosaurs. They're rocks, and that is essentially the problem. So I brought this horse bone. This is actually from a species of horse called a stilt-legged horse, so it's not the same horse as we see running around today. This bone is around 60,000 years old, and you see how it still retains these bone-like qualities in there? You see it's darker on the outside and then lighter colored on the inside. And if we were to drill into it, you could actually smell the collagen burning. You can smell DNA. When you drill into something that is just rock, it doesn't smell like that. It doesn't smell like anything. It really is just rock. Also, it tends to break your drill. And the oldest bone that we've been able to get DNA from is less than 2 million years old. It's somewhere between 1.5 million and 2 million years old. But that is exceptional. The majority of bones that we get DNA from are within the last 100,000 years. And they're also from cold places. So when it's cold, DNA survives longer. Think of sticking something in a freezer rather than sticking it in a fridge or leaving it outside on the counter. Stuff lasts longer when it's cold. The same is true for DNA. And so that 2 million year old bone had been frozen for all 2 million of those years. And there is nowhere on Earth that has been frozen since the extinction of the dinosaurs.
Okay, so it's important for everybody to recognize that this question that is always being asked of Colossal, can you bring back dinosaurs, is a definitive no.
Yeah.
You think about how far away on the time scale that is. 2 million to 66 million, the end of the Cretaceous period. But what we're gonna do now is head into the lab and you're gonna show us how you guys extract DNA from not as ancient bones as dinosaurs.
Yeah, so DNA is preserved in almost all of the elements of an animal. So we can get DNA from teeth and from tusk, from hair, from skin, from bone. And different elements have different qualities of DNA. Just like in the horse bone that I showed you, do you see how the color here changes?
Yes.
We go from the outside, which was exposed to the dirt, and all the microbes that live in the dirt that start to change the outer surface. They start to mineralize that outer surface in the beginning. And then in the inside, it's super light colored, very white,
And
just
that's
like
the good
it's very
stuff in
fresh.
there.
Absolutely, that is where the DNA will be hiding out.
Okay, so we're gonna use a bone saw to cut a section off, and this would be the first step that you guys go through with any sort of ancient bone material. Important to note that this is not actually being used for science. We're just going through the process to show you what the science looks like. Oh, is that the smell of DNA?
Do you smell it?
I do smell
You
it.
smell it already?
Yes, I do. It doesn't smell good.
I love it.
Oh, it smells terrible.
All right, you want to
Okay.
have a go?
Yeah, I guess
So
so.
you want to go at a bit of an angle so it's easy to pop it out. And the other thing that harms DNA is getting too hot. So we do it a little bit and then take it out. There you go. That's probably good.
Okay.
See if you can.
Just chip it out of there like a
Yeah.
little.
There you go.
Get that sample. That is our mammoth tusk sample. So there could be quite a bit of DNA in that if this was a true bone that was being used for science.
If we were going to extract DNA from that, and we could,
Yeah.
we would be able to extract an entire high-quality mammoth genome from this amount of bone.
We're not going to grind this all the way down to extract the genetics from what's in here.
That's right.
But we're going to now walk through the next steps of what Colossal does to extract the DNA out of a more modern sample.
So to generate the genome of an extinct species, we would take a bone, like you just did,
Yep.
and we would take it to a clean lab. We partner with a lot of labs to do that, where we will take that bone and powder it. So we make it so that we can access as many molecules as possible. Then we dissolve away all the stuff that isn't the DNA and capture that DNA in a way that makes it possible for us to sequence it. All right, so
I got our DNA.
what you're gonna do is you are going to open up your tube of DNA. Careful not to touch the inside tip there. There you go. All right. Stick the tip of the pipetter into the liquid so that you can see it. Go to that first stop, stick it in, and now suck it up slowly. Good work, good work. All right, now you gotta put that tube back down in your little plate there. All right, perfect.
Chicken DNA into slot A1.
Right, and now we're going to put this into this robot here. All right, close it.
Close her down,
Now we're gonna hit next. There we go.
and we're off. Now, what is this machine actually going to do?
It's going through the process of making what we call a genomic library.
Okay.
It's essentially adding little bits of DNA to the end of each of these molecules, and they're pre-described bits, so we know what sequence it is that it's adding. After this library prep process is done, and this will take a couple of hours,
Okay.
we will then put it on this machine. It will run overnight, and then we will have billions of sequences of DNA out of that little tube that we will then transfer to a computer to try to figure out which parts of it are chicken and which parts of it are you,
Oh, because we probably definitely got some of me in the chicken sample.
probably.
Yeah.
We'll get tiny little fragments of DNA that we will then use a computer to map to a reference genome, something that's already been sequenced. For the mammoth, for example,
Yes.
we used an Asian elephant genome. Asian elephants are the closest living relative of mammoths. Their genomes are pretty similar. They're about 99% or more the same.
And we're talking about the G, C's, A's, and T's, right?
That's right.
And how those essentially align and look like the Asian elephant, and then you can alter the mammoth genome to more closely represent
Yep.
a woolly species.
So we will generate hundreds of billions of tiny fragments of DNA, and then one at a time, our computer programs will figure out where they line up against the elephant genome. And eventually we can summarize all of that information and know what makes a mammoth different from an elephant. And that is what we then use to design our experiments to modify the elephant genome so we can eventually make a mammoth.
I've got this little mammoth here that will help us set the stage between an Asian elephant and a mammoth, and how you guys will ultimately edit the genome sequence of an Asian elephant to look more like a mammoth. And the big call-outs visually are longer tusks, shorter ears,
Smaller ears,
smaller ears, shorter tail,
shorter tail.
big hump on the back,
Fat deposit to help keep them warm when it's cold,
and a ton of fur.
also for cold tolerance.
Right.
But we have to figure out what in the mammoth's DNA, what in that 4 billion letter code is it that makes these traits different from an elephant?
4 billion.
4 billion. It's bigger than ours. Our genomes are about 3 billion letters, and elephants and mammoths are 1 billion more.
And it's not as simple as being like hair, tusks, tail, ears. It's much more complex than that at the end of the day. And it could end up being tens of hundreds of thousands, millions of edits that need to be made to successfully make an Asian elephant look like a mammoth.
Could be. So our job now is to narrow it down. So one of the things that we'll do to narrow it down is we'll extract DNA from lots of different mammoths. So this is just one mammoth. This is one that we extracted DNA from at some point. But if we did another mammoth and lined it up here, maybe it would still have that G, But if we kept going, it wouldn't have that A. That would mean that at that place where it's an A, it could look like an elephant or it could look different. That we know then is not important to making a mammoth a mammoth.
So it takes many mammoth samples to ultimately break down the code, re-edit that sequence, and then ultimately get to the point where you can even think about creating something that will be born and grow into what looks like a mammoth. And you guys have successfully done this with the direwolf.
With the direwolf.
And now the challenge to do it with a mammoth is well underway.
Underway.
Okay.
It's exciting.
Well, and how does this all tie in specifically to the importance of conservation moving forward? Because it's not just about recreating an animal like a mammoth, it's about protecting species for the future.
All of the technology that we need to develop to get here is applicable to learning about adaptations that make living endangered species unique or able to function in their habitats. As we develop new tools to get DNA from samples, or the genome engineering tools, or the advanced artificial reproductive technologies that we need to take those cells and turn them into living animals, all of those technologies have immediate application to endangered species.
Well, there you have it. That is a huge education very quickly when it comes to how Colossal Biosciences is using the extraction of genetic information to not only de-extinct certain species, but also to preserve species as they're pushing towards the brink of extinction in our current times. Beth, thank you so much for all your time today. I'm Coyote Peterson. Be brave, stay wild. We'll see you on the next adventure. Now, before we run away from this episode, I know you guys wanted to see the mega tooth that Luke pulled out of the ground.
This tooth is pristine. The serrations wrap all the way around the tip because it hasn't even worn the serrations off yet. And usually they have like a wear facet on the side of them there. This one doesn't, so it's a super fantastic tooth with beautiful colors and beautiful serrations.
That's the tooth of a true giant.